Right, thanks for watching. In this video, this is what discuss our question 6. It's a question on chemical equilibrium for this November 2019 question paper. In the description below, uzothola ama-link amanye for my questions engiwarekhodile for this question paper. Our question 6, it's all about the chemical equilibrium. You'll check layer principle, equilibrium constant, so on and so on. Now, lana ke ku question 6 bathi kithi initially 60.8 gram of pure carbon dioxide is reacted with carbon in solid form in a sealed container of volume 3 cubic decimeters. The reaction reaches equilibrium at temperature T according to the following balanced equation. Carbon plus carbon dioxide, it's a reversible reaction, sibana 2 moles of carbon monoxide. So the equation is balanced, then 6.1 that is defined at the term chemical equilibrium. 6.1, the chemical equilibrium is the state in a chemical reaction when the rate of the forward reaction equals the rate of the reverse reaction. So in this sealed container, I have two reactions, the forward and the reverse reaction. So whenever our rates of both reactions are equal, we reach a state of chemical equilibrium. 6.2, at equilibrium, it is found that the concentration of the carbon dioxide is 0.054 mole per cubic decimeters. Right. So basiphe ini the concentration for carbon dioxide at equilibrium as 0.054. Bese bathi calculate 6.2.1 the equilibrium constant Kc for this reaction at temperature T. The T is unknown, it's a temperature esingayazi, but the let's focus on the Kc value for now. Sifuna the Kc value, but first into engizoyenza la ku 6.2.1 ngizocalculate the number of moles for the carbon dioxide. Since the carbon dioxide is given as a mass in grams, so kumele siconvert it to the number of moles. So the number of moles for carbon dioxide is equal to mass divided by the molar mass, equal to, after a substitution, I have 60.8 divided by 12, which is the molar mass of carbon, plus 2 times 16, which is the molar mass of oxygen. So our final answer is equal to, let me pull out the calculator. Okay, so it's going to be 60.8 divided by 12 plus 2 times 16 is equal to 1.3.8. 1.38. Let's see this calculator. Okay, so in 3 decimal places, I think express it to 3 decimal places, so it's going to be 382 moles. 382 moles. So this is our answer for the 60.8 gram of pure carbon dioxide. In terms of moles, it's 1.382. So now we can calculate the Kc value here again. Now, since I'm going to give a space enough, Lana, I'm going to erase everything and then draw the table again. Alright, here now 6.2.1 is calculated the equilibrium constant. So now I have the table for calculating Kc value here too. But first, let's populate the table here with the given values. Initially, for the initial quantity in moles, sine carbon dioxide. Lenka we calculate as 1.382. Your table, whenever we use our calculations, you need to work with our moles only, not grams, not kilograms, not cubic decimeters as well. All right. So therefore, in the initial quantity for a carbon dioxide and the carbon monoxide, since the carbon monoxide is the product, so initially we don't have anything, but initially for the reactant we have 1.382. So what else is given? It's the concentration at equilibrium for a carbon dioxide. So this is given as well. Say plug it into our table. Then, so since this is the given information, now we need to work out lana, na lana, na lana, this block, this block, this block, this block, and this block. But I only need le value la, ne value la, the concentrations at equilibrium for both the reactant and the product in order to calculate the Kc value. But in order to do that, ngizodinga calculate lama blocks engiwamakhile kuqala in order ukuthi ngikwazi ukuthola le value yala. So now into engizoyenza ke manje la ngizocalculate the change in amount for carbon dioxide. And oh, by the way, carbon as include since it's a solid, and the Kc, let's calculate the Kc value. Ama solids are remain constant. The only changes esiba now swathola kuphi kuma gases, right? Whether it's solution, liquid, you don't include it in your Kc calculations, right? So the quantity at equilibrium, ngifuna the moles at equilibrium. I'm working from bottom to the top, right? So bheka bangiphi concentration at equilibrium for a carbon dioxide, I can calculate the quantity at equilibrium for a carbon dioxide. So I calculate using the formula of concentration. So ngifuna the number of moles. I have volume 3, and then I have the concentration is 0.05. So now cross multiply lana the number of moles kuba 0.054 times 3. So it's 3 the volume times the concentration, and got the number of moles. Answer yami it's 0.162. 0.162. So the change initially in a 1.382 at equilibrium ngibana 0.162. So it means that there has been a change from lana to lana. What is that amount of change? I simply do what? Ngizo subtract the two quantities. So ngizoti 1.382 minus 0.162. Answer is equal to 1.22. 1.22, right? 1.22. Now, since sengithole one change, or ngithole a value for a change for a carbon dioxide, it means I can calculate the amount of change for a carbon monoxide using a stoichiometry. So for every one mole of carbon dioxide that reacts, 2 moles of a carbon monoxide are formed. So therefore, in a 1.22 lana, so the value for ngapha it's 2 times this value, since it's 1:2 ratio. It's a 1:2 ratio. So ngizoti 1.22 times a 2 times by 2, you total out 2.44. 2.44. Now bheka ke manje, initially the quantity was 0. The change now is what? Is 2.44. At equilibrium izofana ke 2.44. So the change value, the change value is the same as the reacted amount, ne? Is the same as the reacted amount. So that's why I say stoichiometry la. Ngoba ngifuna the reacted amount of a carbon dioxide, or not the reacted amount, the formed amount. This is the reacted amount. Na reactor na le carbon forma 2.44 of a carbon dioxide. So that's the change. I don't like this table ngoba you one-sided. You focus only guma reactants. They were supposed to say lana change or formed, or reacted and formed number of moles. So the reacted amount is 1.22 for carbon dioxide, and the formed amount is 2.44 for a carbon monoxide. So since this is the formed amount, at equilibrium uzosala 2.44 as well. So therefore we can calculate the concentration again now for a carbon monoxide. So sebenzisa this formula, 2.44 the number of moles n divided by the volume of 3. Answer is equal to 0.813. 0.813. Now saying the concentration at equilibrium for carbon monoxide and the concentration for carbon dioxide. So therefore the Kc value is over equal to the concentration of carbon monoxide squared divided by the concentration of carbon dioxide. Why since I included this one, it's a solid, it remains constant again. It's a constant, so as I include the formula it. So this is equal to concentration of carbon monoxide 0.813 squared divided by carbon dioxide 0.054 equal to, answer it is about equal to 0.813 squared 0.054 equal to 12.24. Our answer is 12.24. 12.24. No units, it's a constant. So therefore our Kc value for this question is 12.24. 6.2.2 in this question is funa ukuthola the minimum amount of carbon that must be present in the container to obtain this equilibrium. So in other words, it's funa mass carbon, right? So 70 stoichiometry again. So the reacted amount for, remember initially starting how much? Now 60.8 grams of carbon dioxide. So therefore lana ke, in order to calculate the mass carbon sizosebenzisa the amount of carbon. So the number of moles is 70 stoichiometry again for carbon dioxide is equal to calculated as what, 1.22, is it 1.22? Wait a minute. Okay, yeah, it's 1.22 moles. I'll explain in a moment. Let's go back to our table, the Kc value. Right, so the reacted amount was 1.22 for carbon dioxide. We cannot use the initial amount as a whole. We cannot use the 1.382 as a whole. Why? Ngoba this is the initial amount. We only want the reacted amount. The reacted amount is how much of carbon must be present in the container to obtain the equilibrium. Now let's go back to 6.2.2. Now, so since this is the reacted amount of carbon dioxide, now using stoichiometry, for every 1 mole of carbon that reacts, also 1 mole of carbon dioxide will react. So therefore it means that if ever your reactor 1.22 mole of carbon dioxide, it also means that 1.22 mole of carbon will also react because of there's a 1-to-1 ratio. Now since stoichiometry, just look at coefficients for this reaction. So therefore the number of moles for carbon is equal to 1.22 mole, but it's for the mass, not the number of moles. So mass is equal to number of moles times the molar mass. So it's 1.22 times 12. 1.22 times 12, the mass is equal to times 12. Answer is 14.64. 14.64 grams. 14.64 grams. So siya ku 6.3 ke now. 6.3 bathi how will each of the following changes affect the amount of carbon dioxide at equilibrium? Sifuna ukwazi ukuthi how will the amount of carbon dioxide be affected if one of the following changes they take effect. So from increases, choose from increases, decreases, or remain the same. 6.3.1, but more carbon is added to the container. So since this is a equilibrium or a reaction a reaches a state of chemical equilibrium, a reactant or a product in solid form, where do I increase or I decrease, I won't make any effect to reaction yakho since I affect our Kc value. So it means that if ever increase or more carbon is added to the container, the amount of carbon dioxide won't change. It will remain the same, right? Since carbon doesn't play a bigger role kule reaction yethu at equilibrium. So for 6.3.1 sizothi ke lana it remains the same. It remains the same. Now 6.3.2, the pressure is increased by reducing the volume of the container at constant temperature. So the only thing a change in this case in pressure. Pressure is being increased by reducing the volume of the container. But we say to use Le Chatelier's principle to explain your answer. Sifuna ukwazi ukuthi carbon monoxide izoba affected kanjani if we increase pressure. Carbon monoxide will decrease in this case. Why? Because according to Le Chatelier's principle, an increase in pressure, it favors the side or the reaction with the smaller or the smallest amount of moles. So bheka on the left hand side ngina ngaki, on the right hand side ngina 2 moles, on the left hand side ngina 1 mole. I don't include the number of moles for the solid. So from 2 to 1 it's a decrease. According to Le Chatelier's principle, the reaction or the side with less moles will be favored. So from 2, it means the reverse reaction will be favored, since on the reverse reaction has lesser number of moles than the forward reaction. So from left to right, there's a decrease in the number of moles. So an increase in pressure will favor the reverse reaction. Thus, the concentration or the amount of carbon monoxide will do what? Will decrease. So the answer here to lana city is a decrease. 6.3.2, it decreases according to Le Chatelier's principle. An increase in pressure favors the reaction with a smaller number of moles. Therefore, more carbon dioxide is formed. So therefore, the amount lenienzani ya decrease So siya ku 6.4, where there's a given table, but the table below shows the percentages of carbon dioxide. Or let me do this. Let me pull out the actual table. Alright, now the table here together. But the table below shows the percentages of carbon dioxide and carbon monoxide in the container at different temperatures. At 827, the percentage for carbon dioxide 9, for carbon monoxide 9. Temperature 950 now my percentages for the carbon monoxide and the carbon monoxide. 11050 now my percentages wakhona. 1200 now my percentages wakhona. Mawuthatha ukubheka, if ever a temperature increase, more of a product is formed. Carbon dioxide eningi iyafomeka, uyabona? And the percentage of the reactant of a carbon dioxide, it does what? It decreases. 6.4.1, basibuza ke, what is the reaction exothermic or endothermic? Refer to the table, to the data in the table and explain the answer. Okay, according to Le Chatelier, let's just visit Le Chatelier for a moment. we know that if ever we increase a temperature, the endothermic reaction will be favored, right? It will be favored. So now on this table, I'm increasing a temperature and the products are being formed, right? More products are being formed. So it simply means that if forward reaction here too is actually endothermic, right? Is endothermic. So is this reaction exothermic or endothermic? Minangiti, it's endothermic. 6.4.1, it's endothermic. Why? Here's a reason. Sisebenzise i-table and provide a reason. When the temperature increases, the amount of the product produced increases. Therefore, the forward reaction is favored, right? It's obvious. Lena observation esithola from the table. Let's add the reason galichetla bengichaza manje. An increase in temperature favors the endothermic reaction. So therefore, more products will be formed because of the forward reaction in the endothermic reaction, right? 6.4.2, use the information at the table to determine temperature T. Temperature T, remember, if ever ukhumbula kahle, before sizoqala ngalelo, like on the first question or the first statement, they did mention something about the temperature, right? They did mention something about the temperature. The reaction reaches equilibrium at temperature T. What is the temperature T for this reaction at chemical equilibrium? What is the temperature for this reaction at chemical equilibrium? So lana ke sifuna calculator the temperature T using the information abasiphe yona kule table above. So in order to calculate the temperature T, sodinga calculate ama percentages either for carbon dioxide or carbon monoxide, ne? If ever answer yami iphuma is 99, if okay, let's say calculator a percentage production, like nangikhuluma lama percentages lawa abakhuluma ngawo la ama percentages at equilibrium for the product and the reactant. So if at equilibrium, by the way, so ngizosebenzisa ama quantities, ama number of moles at equilibrium to find our percentages. It's either to calculate the percentage for a carbon dioxide or a carbon monoxide. Let's say answer ngithola is 99.63. Ne? It means that the temperature T to go about 1050 or 1050. If ever answer iphuma is 98.68, go about temperature to T is simply 950. If the percentage for carbon dioxide is 0.06, it's the answer to give about 1200. So lana so calculate a percentage either for carbon monoxide or carbon dioxide at equilibrium. So 6.4.2, the carbon dioxide at equilibrium from the table, she calculated 0.162. For the carbon monoxide, the number of moles from the equilibrium table, she told is 2.44. Right, since you calculate a percentage either for a carbon dioxide or a carbon monoxide, I need the total number of moles at equilibrium for the reactant and the product. Remember, it's solid here to say exclude in our calculation. So nang add lana ngithola ukuthi our answer is 2.602 moles. So mina I choose a calculator carbon monoxide. So calculator a percentage for a carbon monoxide. So let's substitute again. Since in calculator a percentage, ne? Calculate a percentage la for a carbon monoxide. So in order to calculate the percentage, you tata the total, you divide the the number of moles for a carbon monoxide divided by the total times by 100%. So therefore it's 2.44 divided by 2.602 times 100 is equal to what? Let's calculate. See, calculate 2.44 divided by 2.60202 times 100. Our percentage it's 93.77%. So since the percentage at equilibrium for this reaction here to layer is equal to 93.77 for a carbon monoxide, it means the temperature here too. Now temperature here, it means the temperature here too. Our temperature is equal, our temperature T is equal to 827 degree Celsius. I can also do it in carbon dioxide if ngifuna. The carbon dioxide yona izosinikeza, let's calculate, izothini ke yona, izothi 0.162 divided by 2,062 times 100 equal to 6.23% in 2 decimal places. Yes, in 2 decimal places. So the percentage for a carbon dioxide is 6.23. So it simply means that our temperature is 827. So it doesn't matter ukuthi wenza this one or this one. So yeah, question here to question 6 uphelela lana. Thanks for watching. Now we enjoyed this video, leave a like. Now we a question, let us talk in the comment section. Now we new to this channel, please consider subscribing, guys. If you told some value out of this video, share as well. So thanks for watching. Asibonane on the next video. Bye bye.